I want to look briefly at that situation where we had with the snowboarder, and we had a guy jumping a certain height, call that H, and then he lands on the snow, and we get within B a force from the snow stopping him. Now we were able to work out that reaction force reasonably easily, because that was just the work done by the reaction force times the distance B to get a change in the total energy from the top to the bottom, total energy being mg times h plus b. So we end up with the right reaction force if we do that, and that's not the situation I really want to look at. If we now want to ask ourselves, what is the time for this force to act over that distance, using the impulse equation, then we might think that we can use this reaction force that we already developed. But this is one of those situations where we actually don't just have a velocity. So if we go back to this point here, we'll all remember that the velocity at that point will be equal to the square root of 2gh. Now the impulse equation says that change in momentum is equal to the reaction force multiplied by the time it takes. So the velocity goes from v here down to 0 here. So that truly is the change in momentum. What I want to bring up here is that we actually can't use this reaction force, because that force that force is made of two components. It isn't just changing the momentum from this velocity down to 0. It's also stopping an increase in momentum. Normally at this point the velocity would increase during that section when it's going from h to h plus b. The velocity would be even greater, but it's not greater because we have part of our reaction force is equal to mg. So if part of our reaction force is equal to mg, then that part of the force is just stopping an increase in momentum, and we wouldn't be able to use the whole reaction force to get the change in momentum. So as long as we subtract the mg component from that reaction force, we're going to be alright, and this change in momentum equation is going to work. That's the point I wanted to bring to your attention.